So the tutorial that we're running today is using InstaGENI with Flack. So unpacking that, InstaGENI is there are two Genie Racks projects that are putting Genie-enabled infrastructure on a bunch of campuses. InstaGENI is one of those two. And what we're going to be doing today is using a web-based tool that we've built in the Proto-Genie project. This web-based tool is called Flack. We're going to use it today to make a slice on the InstaGENI rack at the University of Utah. The same basic tools and same basic process will work on other sites that support the Genie Aggregate Manager API. And because we've got an hour and a half, what we're going to do is we're going to go through creating a pretty simple little experiment, a little bit of traffic, and just to kind of get you guys the flavor of what it looks like to build a slice using Flack and using InstaGENI. So if you're using the VM that's provided, password for it is GEC15 user. That's all lowercase. Again, it is possible to do this using your own web browser. The advantage to using the provided VM is that we've tested it and that it has SSH keys so that you can log into machines once we get up. But if you can't get the VM working, don't worry about it. You can make do just with your own web browser. So if you are using the VM, please use Firefox. There is a bug in the version of Chrome that is installed here. Chrome does work with Flack in general. The version of Chrome that's in this VM doesn't work for some reason. So the first thing that I'm going to have you do is I'm going to have you log in to Flack. So if you were using this, I'll actually at the end talk about the process of getting an account. After we're all done, we'll jump right into creating our slice. So again, if you're using the VM, there's this little drop-down box and a link for the Flack Genie client. If you're not using the VM, there's a Flack URL on the little piece of paper that we gave you. It's protogenie.net/Flack. And when you fire it up, it's going to present you with a screen to log in to start looking at Genie resources. Oh yes, that's right. This VM wants to update the software. Nope. And so it's gonna bring you up to this login screen. Now, there are a couple of different things you can do here. So first of all, if you click on this tutorial, it'll actually take you to a web version of the tutorial that we're doing today. There is a link to that tutorial in the bookmarks. It's also written out on this piece of paper. It's the second URL in here. So if I'm going too fast for you or too slow for you, then you can actually follow along on the web with all the steps. So Flack lets you view Genie resources even if you're not logged in using this button down here, but we're actually going to log in today. So go ahead and click the login button. And did I actually click it? Oh, there we go. Now it's going to give you the screen. Now what it wants in this screen is a certificate, an SSL certificate. So all authentication to Genie services is done using SSL, and so Genie users are issued these SSL certificates, and we've pre-created a user account for you. What you're going to do is I'm going to have you pick the select authority drop-down box. You could have an account at one of many different places. An account at any one of these places is actually accepted at all of them. The accounts that we've pre-made for you are at the emulab.net authority. So you'll want to select that. And then click download. And what's going to happen now is it's going to give me this error about getting a login page. Let me ask, can people in the back read the text on my screen, or is that too small? That's too small. It's too small? Okay. Let me adjust my resolution and see if I can force a larger font size. Let's see. And Oh, there we go. So that's probably not a lot better. I'm hoping it's a little bit better. Yeah.
Did you go with the password for the
So again, if anybody didn't get this, the password for the virtual machine, if you're running the virtual machine, is GEC15 user, all lowercase. Okay, so is this a little bit more readable now? Okay. So what this is telling me is that the certificate isn't loaded into Flack yet. We actually provide a service where you can automatically download your certificate. Now, you can also manage it yourself. You can keep it on your desktop machine and paste it into this box, but we're going to use this feature that automatically downloads it. So what it's going to do, so it's offering to let me log in. I'm going to click the yes button here, and it's going to take me to a page where I get to log in using the information on this sheet. So I've already logged into this browser, so it already has my email address or username in there. But so you're going to take this top box and you're going to put in the username that is the first item on your handout, and then the password is the second item on your handout. And I will stop in just a minute to make sure that everybody is caught up, but I'm going to get through this step. So I put in the username and password, I click login, whatever. And then now I can go back to my original tab and say download the certificate, and because I'm logged in, it gets downloaded. Now I'm going to stop at this point, and I'm just going to kind of check and make sure that people are getting this far, and we'll start up again in just a second. Most people have gotten to this point, so I'm going to move on. Again, if I get like out ahead of you, there you can go to this you can go to the tutorial URL that's listed on here to kind of follow up, or if you get ahead of me. And if you're having trouble, you can raise your hand, and we have a couple of people who are kind of circulating around who can help. So now that I've got my certificate downloaded, it's encrypted with a passphrase. And the reason that there's both the login and the passphrase is that I could actually take the certificate, and I don't need to go download it from the Emulab website every time. I could save it on my laptop. Flack will actually cache it, and so to actually use the certificate, I'll have to type in a passphrase, which is the third thing that's on your handout here. Oh, and I got it wrong. And so once, and I understand it's probably going faster for me because I'm on a wire, and I gather that the wireless in here is pretty slow right now. But so I expect that it's going to take a little bit longer. What's going to happen once you log in is you're going to be presented with this list, and this list shows you all of the aggregates that are known to Flack. So I believe most of you were in the session before this, the Introduction to GENI session. Is that correct? Is there somebody in here who doesn't recognize the words slice and aggregate? Because I'm happy to spend some time on talking about that. Okay. So the aggregates here are individual installations that support GENI, that have computers, that have switches, and that are each autonomous. So this federation that we're running, and they're all federated together. So the account that I have that comes from Emulab works on any of these. And there, as you can see, there's a whole bunch of them that are currently federated. We're only going to use one of them for our tutorial today. So there's a box at the top that lets you select or deselect them all together. So I'd like to have you deselect everything. And then there is Utah GENI Rack, which ought to be in the second row on the bottom, and select that one. That's the one we're going to use for our tutorial today. Later on, after the tutorial, if you get ahead in the tutorial and you want to play around and look at what other resources are available, you can actually come and check some of those other boxes and look at other resources. So I'm going to check only UtahGENI rack, and then I'm going to continue, which is now going out, and my instance of Flack is going out to the InstaGENI rack in Utah, and it's asking it for an advertisement which describes the resources that this rack has. And let's see. And it will take just a minute here because it has to actually go out and it has to actually generate the list of available resources. And so you can see it's come up. It's probably impossible to read from the back of the room, but there's a little 7 in that box, which indicates that there are 7 machines available at at this particular site, and it shows up in Utah. If I selected some of these other ones, like Utah Emulab, I would get a bunch of resources shown to me all over the world. So let me click through and kind of give you an idea of what we've got here. So I can, and I'm very sorry, this color, I'm sure this color is completely impossible to read. But what this is showing me is that I've got I've actually got 5 PCs that are available at this site. There are some other nodes. Actually, it's easier to see on the left-hand side. These connect to the internet. There's a switch that they also connect to. And I want to draw your attention to these little icons here, and these little ones that look stacked are shared hosts. And those are the ones we're going to use today. And they give you virtual machines to run your experiment in. It's also possible to get to allocate physical machines for your experiments as well. This rack has 5 machines in it, so there's only 2 physical machines. So clearly, we're not going to give everybody a physical machine today. And there are various tools here if you want to do things for search for machines that have certain amounts of physical RAM or physical CPU, physical RAM or physical CPU or whatever. So you can use this to find machines that actually match what you need. So the next thing I'm going to have everybody do, let me actually stop at this point and ask how many people are basically sitting at this screen seeing the number of resources in Utah.
I'll point out that the wireless appears to be working again.
Oh, okay.
So
great.
If you try and re-DHCP for an address.
Yeah. Okay, so it sounds like most people are here. Again, if you're having trouble, raise your hand, and there are a couple of people who can come help you out. So what I'm going to have you do next is create a slice. So there's this button up here under my username that says new. It's got a little magic wand, at least I think that's what it is. And it's going to ask me to pick a name for this slice. Now, Lee, looks like Chip is pointing out something he needs to tell. So there's these slice names need to be unique. So we've written down a slice name on your handout to use, just so that not everyone says test or tutorial. So I'm going to have you type in that. Oops. It's not the name doesn't matter as long as it's unique, really. And I'm going to click OK. Now what's happening here is that the slice is, you can think of the slice as the container for the resources that I'm going to allocate. So when I create this slice, I'm not going to immediately get any resources allocated to it. I'm going to get a container that I can then go around and say, please put some resources in this container for me. So at some level, oops, I didn't click OK. At some level, a slice is just a name to which I'm going to attach resources that I'm allocating. And just a moment. Oh, I see what happened. Okay, I have to pick a different name because to make sure things were working this morning, I already created one. Okay. Okay, so I want a quick show of hands. How many people have made it to this screen? Pretty good, pretty good. Okay, so what this screen is giving me is a canvas on which I can draw the network that I want to run my experiment on. So what I'm going to have you folks do is I'm going to is we're going to draw one and then we're going to throw it away and use a canned description that I've pre-created so that we make sure everybody's slice looks the same. So what I see here in my palette is I see this UtahGENI because that's the aggregate that I loaded. And now when I drag over this PC or this VM icon that's next to it, so I'm going to click this, drag it onto the palette, let go. And so this is going to later, when I choose to submit it, ask for a virtual machine to be allocated on the InstaGENI rack at Utah. So let me drag 3 virtual machines out onto the canvas. And then let's look at a couple things, a couple pieces of how this works. So first of all, clicking on the X button on any of these makes it disappear. And remember, these are not allocated yet. I'm just still drawing my topology. Clicking on the I button brings up a little bit more information. So first of all, if I want, I can rename these machines so that once my slice is created, I can use the names that I picked to refer to them rather than having to worry about which virtual machine I got or which physical machine I got. I can also, I can pick a, let's see, oops. I can pick a disk image, and I'm not actually sure why this is blank. But basically, I will demonstrate this for you with a PC, which should actually show it to me. So we provide a number of default operating system images that you can use on your machines. You can see, for example, we've got FreeBSD, Ubuntu, Fedora, and I can pick out of this list. As a user, I can also create my own virtual machine image, and we'll be demoing that later tonight. So if you're curious about it, you can come by the demo session tonight. Another thing that I can do is you'll see this add install service button here. I can give it a URL for a tarball and tell it where on my physical or virtual machine I want to have it installed. And as part of the process of creating the slice, that'll get put down. I can also give it a command that I want to have run when my node boots. So basically, I can use these two together to kind of bootstrap my experiment. So the experiment that we're going to run today has some very simple traffic sources and sinks, and those are going to be in a tarball, and we're going to start them automatically with a command. If you want to install a relatively small amount of software, this is a good way to do it. If you need to install a large amount of software, like a bunch of packages or something, a nice way to do that is to take an image, is to create an experiment, get everything set up the way you want, and then take an image, which you can then load on your other in future slices. Next thing I will show you, so I'm going to get rid of that PC. So I can draw links between these things. So if I hover near one of the nodes, this little line pops out, and if I click and drag that to someplace else, that creates a link between the two. I can actually create, we're not going to use this for the experiment today, I can actually create LANs by connecting a node to one of these little LAN boxes that pops up in the middle of my links. And I can set properties on these LANs if I want. So I can go to these LANs, I can click the info button, and I can set things like what the IP address ought to be for these, or properties of the speed of the LAN, or these kinds of things. So I want to stop at this point and this is a good point to ask questions. So any questions about what I've said so far? Yeah.
So when we configure the network length,
Yeah.
I understand that you're able to choose between different sites. Like for example, I choose one at the East Coast and one at the West Coast. And that link, even with the backbone, will have a delay of its own.
Yeah.
And then if I configure the network to have a delay of 60 milliseconds, would the delay that I will experience be a combination of those two or just this one?
Okay, so in case people couldn't hear him, so the question was, so if I connect nodes at different sites, there is some delay on that, and if I try to add delay, does that delay get added to the backbone to the natural latency, or does it get or is it somehow canceled out? So first of all, not all of the sites currently support layer 2 connectivity. There are a number of them that do, and that number is growing. But something that right now I am likely, if I ask for multiple sites, I am likely to get a tunnel, but rather than a VLAN. If you ask for an additional delay on that link, that's going to be added on as an additional delay. So if it's got naturally has a link a one-way delay of 50 milliseconds, and you ask for a 50 millisecond delay, you'll get a one-way delay of 100. There's no attempt to cancel out the delay that's inherent on that link. And in general, I don't think there's a lot of point in asking. I mean, generally, the reason to ask for increased delay or whatever is to emulate geographical distribution, right? And so usually, you either put them all in one place and emulate the geographical distribution, or you just use really geographically distributed stuff and just take whatever you naturally get. Any other questions before I? There's actually one feature that I forgot to show you that's rather important. So if I go and look at the information page for my LAN, there is a where is it? Yeah. So on this link tab, there is a link down here that says Routable Control Ip. So because we're using virtual machines at sites that have limited public IP addresses, you're not guaranteed that when you ask for a machine that you're going to get a public IP address. For many experiments that are kind of inward facing, where all the traffic that you're interested in sending is between the nodes in the experiment, there's not a need for a routable control net. However, often you'll want to be able to start up a web server, offer some service to the outside to outside users, and so checking this box on individual nodes will let you request a routable IP address for those nodes. So, for example, if you have a web server and a couple backend database servers, you might go only to the web server and check this routable box. So, at this point, I'm going to throw all this away. There is a little reload button that is in the panel in the bottom. What this is going to do is this is going to sync Flack's state with the actual state of the slice. So in this case, because I've not actually created the slice, clicking this button is going to, I've not actually reserved these resources, clicking this button is going to end up with a blank canvas, because it goes out and says, okay, what do I actually have? Okay, nothing. So what I'm going to do is look at this import. There's an import link here, and I'm going to say import from the web. So I'm going to give it a URL of a resource description, and we'll look in just a minute at what that resource description looks like, and tell Flack to load that. Now, there's two ways you can get it in here. If you look on your handout, there is a RSpec URL. It's the bottom thing. You can type that in. Alternately, if you're using the VM, there is, let's see, I got to go out of full screen mode, I guess. If I go to the bookmarks, there's this, under Flack, there's this tutorial RSpec bookmark, and if I right click, I can copy it and just paste it in here. In theory. There we go.
So Rob,
Yep.
once you're running through the loading the RSpec, you can import.
Okay. So in case you missed this part, so what I just did here was I said I wanted to import a description from the web. It popped up a box asking me for a URL, and I put in the URL that's on the bottom of the handout. And you'll notice this looks kind of like the thing that I just drew, except that we've sort of pre-set it up to make sure that it contains a bunch of things. So I'll show you what some of those things are. So you'll notice I mentioned this install tarball. It's got something in here that's going to run a simple experiment for us. It's got a script that's going to run to actually start the experiment. It has things like IP addresses configured on its interfaces. And if I go and I can actually, if I want to see what this RSpec thing looks like, there's a view menu here, and I can go preview request documents, and this pops up this big nasty mess of XML. This is the actual experiment description language for GENI. So essentially, one of the purposes that Flack serves is it is a tool to generate these experiment descriptions. So you can generate these things by hand. There's the Omni tool that the GPO has developed, has its own tools for generating this. You can write a script to generate this thing, it's the documented format. It's looking at it, looking at an example that like Flack generates, and then using that as an example is kind of a nice way to go. So at this point, I've got this ready to actually ask for resources. We're going to try to kind of stagger people clicking the submit button so that we don't have too much congestive collapse. So I'm going to click it. Don't click it yet. And so what I'd like to do is, can I have like the first 3 rows over here? Go ahead and click it. And then I'll step through and give everyone else permission to in a minute here. So what's happening now is that Flack is going out to the aggregate and requesting that, and sending this description and actually requesting those resources. And there's actually a 2-step process. One is the step of requesting a reservation, and the other is a step of actually cashing in that reservation, if you will, and asking for the things to be instantiated. And so you see, and if you can read it, you can see I'm currently on the step of redeem ticket, which means I've got the reservation and I'm currently in the process of waiting for it to be made available. What you'll see is that once my ticket is redeemed, the background for Flack is going to go yellow, which indicates that it's in the process of provisioning my resources. Oh, there we go. And then when it's actually finished, you're going to see this turn green. Lee, how much time do you think I should give it between rows clicking? Can I let the next few guys go?
Once you get, is yours finished yet?
No.
Okay, wait a few minutes.
Okay, so we'll wait a few minutes. So what you can do, I've got a question from back here. Or do you guys need help, or do you have a question?
There was a zip file that you recorded. Can you tell us the URL to get there?
Yes. So again, so this is the from the import menu. It's on your handout. It's the bottom thing.
Great, thank you.
Yep. If I wait for this to finish, it's going to be forever.
I know, I'm just trying to see what
Okay. Okay. Yeah. Uh-oh. Yeah. What? So what's the typo?
The R spec, it's the same one as the tutorial.
Oh, no. So the tutorial URL and the RSpec URL differ in that the last one is .xml and the tutorial is .html. So as you saw, so the RSpec format is an HTML based format. While we wait for this, Rick, do you want to? Hey, Rick McGear, do you want to talk at all while we're waiting for stuff to happen about like what the InstaGENI racks are? I know. I'm sorry to put you on the spot.
You know, they're racks. They have
The racks.
Thank you, everybody. So how much time am I supposed to kill?
I know you can kill a lot, but just a couple minutes is good. Oh, so just a second, before you start, Rick. So mine has succeeded. So back half of the second row, go ahead and click submit.
So fundamentally, there will actually be a 20-minute talk in the Genie Rack session tomorrow. But what I claim is that there are a couple of things about an InstaGENI Rack. First of all, the hardware is a boss node. A boss node which is disk heavy which is disk heavy and compute memory light.
You guys can click. Oh, you did. Oh, okay. Yeah.
Which are disk light.
You guys, you going? Good. Okay. Good.
So
Okay.
the boss node is going to be effectively
finished actually pretty fast, so pretty rapid.
I know.
I have all the images.
Yeah. Yeah. Nobody else up here is finished yet. But yeah.
For those of you who are any lab users, it's a place where you put your stuff.
Yeah, the Wi-Fi thing is just killing it.
And storage
Everybody's
images,
really.
at least a little cache copy.
I can't get on. I just tried again. I said,
Storing data, at least a little cache copy, and storing your
make it on.
product files, etc.
So like no IP address or
No, no IP address again.
he's got an IP address. He just needs help.
He needs help.
But they're quad core dual socket, 3 gigahertz Xeons. So that gives you 2 times 4 is 8 times 5. That gives you 40 CPUs. You're doing actually maybe 6 core now.
There's 6 core.
Yeah, sorry, there's 6 cores. So 60 cores of computation. We sized it out with memory at 4 gigabytes a core. So first of all, he basically gave me the spec. Then I threw it at the hardware guy and said, turn this into part numbers. And then we sized price. They've got, we sized it out at 4 gigabytes per core in memory. So there's like, you can do the math, right? 48 gigs on each machine. And I think Rob has managed to get up to 100 VMs going.
Yeah.
At one point, yeah. So one of the challenges we got from GPO was to put 100 slices on one of these things, and we did. Very much, but we did actually get that done. There's a 5406. There's a 5406 in the rack. There are 4 1 gigabyte. There are 4 1 gigabyte. 4 gigabit mix on each port. There are going to be there's a 5406, which is an open flow gigabit switch.
Oh yeah.
Next line cards, the V2s in the rack.
Yeah. Let's see what happened. Okay, one of them failed to come up.
And the thing is designed to be expanded. So the base software installation, as I think you guys know.
So what I would recommend you do, you hit delete here, and then go ahead and pick. Yep, there. Yep.
Just saw you standing there looking.
And then go back to the import, load it again, and try again. I'm not sure what failed.
So anyway, so it's just Emulab. So you're used to it, and moreover, as you know, Emulab can run an awful lot more than 5 nodes, right? So what that means is that you can plug other stuff in the.
I can't follow.
You can put other stuff into the rack.
So new.
And we're currently taking, I think, the 5406 is a 4U switch. So
Yeah,
all
that
of
name.
4
Yep.
plus 5 is 9, and then we have a little baby switch on the top 10 plus a power unit, a couple of power units actually, so 12. So we're probably needing something on the close order of 30U free to stick in whatever you want, and we would really, really like you to stick stuff in. Right. At the also the 5406, you'll see when you get a hold of the thing, there's
No,
lots
just
and
wait.
lots of space.
You can go ahead and click submit. That's
There's
fine.
lots and lots of space for more line cards in. So you can beef up the networking on this pretty easily too. Again, just by
If you guys want to go ahead and submit, that's okay.
the other thing,
If you want to click submit, if you haven't already, that's okay.
But we didn't have the money. Because in order to get a lot of these things out, I had to make pretty bare bones. There's a HP makes this thing called a one services mode, which is essentially a Linux, which is a Linux.
Yeah.
code that you can
Yeah, that's what I've been. Man, this colored background is awesome. You can sit back here and see. We've had one failure. Yeah.
So when he loads the XML file, it just goes into an uncut error, looping and looping. And I had him reload Flack, and it just won't take the XML file.
I have no, and this is with Firefox? I have no idea.
This is the virtual.
This is in the virtual box, yeah. I have never seen this error before. You might try just using your regular web browser and see if,
Your Firefox or Chrome.
yeah, try your regular Firefox and see if there's some kind of, yeah, it's you know what I mean, that's same, right? No, we had one person in the last tutorial who had a similar problem, but
Is that it will take a week to bring up protein on these things. But if we get them some information out of the factory, it'll take a day. We're currently working at the factory to see if we can get that information. The racks will arrive pre-wired. So this is one of the things we offer. The rack comes out and the cabling is there, so all you have to do is plug it in. This was something Rob asked for after the rack that went to Utah arrived unwired. He spent several uncomfortable hours wiring the thing and wrote me and said, "You just know that this is one of those things that's going to go wrong." So we stopped doing it, and so now we've arranged for all the racks to arrive pre-wired. The other thing about the hardware that's fairly nice, I don't think this is unique to HP. This is certainly not unique to HP anymore. Once upon a time, it was a good selling thing. We have a remote management, a little remote management CPU and thing. So it's thoroughly autonomically manageable. And ours is pretty capable, right? Because we've been doing this a lot. The integrated lights out option. So we put that on the switches, which is a blessing to
oh right, you guys are doing it a second time. Yep. So how are you? So yeah, import
Got a
web.
this was because one of my lessons.
That yours, the bottom one.
Was spending a day at what was then Central in Moscow. And I learned painfully that remote management is a very, very good thing. So anyhow, these things are designed so that Rob can run them all from Utah, or when GMOD gets up, they can all be run from GMOD.